Completed when?
Yes, sir, completed.
Now suppose at t equals to 0, particle is at equilibrium position. That means see here the particle is there. So this is the projection now. So what is phi? Can you tell? Phi is 0 no?
Yes, sir.
Yesterday we have seen that. See, mean position means this is 0 at what time? So what you have? So sin phi is 0. Therefore phi is 0. Understood this? Therefore what you have here? The equation displacement is given by this. Understood this?
Yes, sir, understood.
Okay. Now suppose at t equals to 0, particle is at extreme position. That means y equals positive extreme. For example, y is plus a at t equals to 0. So what is the equation? Y equals sine omega t plus phi. This is a sine omega into 0 plus phi. So what is sine phi 1? Phi equals pi by 2. Therefore y is given by a sine omega t plus pi by 2. You get a cos omega t. Understood this? Is it clear or not?
Yes, sir.
Shall I turn this?
1 minute, sir.
The particle is here. Shall I turn this?
1 minute, sir.
1 minute, sir.
Finished?
Completed, sir. Yes, sir.
Now suppose the particle is neither at mean position nor at extreme position as t equals to 0. That means the particle is located somewhere here. Say it is at an angle phi. Then what is the displacement equation? Is the displacement at any time t. Understood this?
Yes, sir.
Yes, sir. Understood.
Suppose is at mean position. That is at t equals to 0, y is 0. Therefore, what you got previously phi. So at any other instant, this do this. Agreed. Now you can see that the velocity dy by dt, that is omega a cos omega t. What is cos function? 1 minus sine square omega
Yes,
t.
sir. Omega t.
Omega t, this is nothing but 1 minus y by a whole square. So this is omega a square minus y square by a square. So omega a by a root over a
A
square
square
minus y
minus y
square.
square.
Understood this? Is
Yes,
it
sir.
clear or not?
Clear, sir.
So this is the velocity of particle at a displacement y. Finished this?
1 minute, sir.
1 minute.
Completed, sir.
So this is, if you look at this, what you got? Now you can see V is the minimum. When can you tell?
Under root a square minus y square is equal
Y
to
square
0.
is maximum. This is constant, no?
Yes, sir. Yes, sir. Y square is minimum, na, sir.
This is minimum. When this is minimum, that should be maximum, no?
Yes, sir. Yes, yes, sir. Got it.
so that V min will be that gives you omega root over, that means therefore velocity is minimum and equals to 0 when particle is at which position?
Extreme.
Extreme.
Maximum position. Extreme.
Followed.
Yes,
Similarly,
sir.
V is maximum
Y is minimum.
when y square is minimum. What is the minimum function of value of y? A
Zero.
square function will have 0, no?
0, sir.
Minimum
Yes, sir.
value of square function is 0. This is a square minus y square. So V max equals omega root over a square minus 0 square omega a. Do you agree with this?
Yes, sir.
Understood this?
Yes, sir.
Yes, sir.
Finished this?
1 minute, sir.
1 minute, sir. Completed, sir.
Completed?
Yes, sir.
So here you have velocity and acceleration is dv by dt, omega a d by dt of cos omega t. Derivative of cos is what? Remember, minus omega square a sine omega t. This is minus omega square y, no? So acceleration is minus omega square y vectorially. That means, note on this. So here, modulus of acceleration Agreed.
Yes, sir.
Because kinematic equations are applicable only if
Constant acceleration.
acceleration is constant. Shall I turn this?
Yes, sir.
1 minute.
Madam? Madam?
Yes, sir.
Call up the absentees. Shall I turn this?
1 minute, sir.
Keep the list of the absentees. Completed.
Yes, sir.
Yes, sir. Completed.
Now you know that mode of acceleration. So acceleration will be minimum if y is a minimum. What is the minimum value of y?
0, sir.
Therefore, acceleration
0.
when particle is at
Mean position.
Mean.
okay, and acceleration will be maximum
Y is
if
maximum.
remember
Yes, sir.
it is clear.
Yes, sir.
Understood this?
Yes.
Next, acceleration is always directed
Towards the center.
towards the equilibrium position.
Equilibrium position.
Yes, sir. Very nice.
Understood this?
Understood.
Shall I turn this?
1 minute, sir.
Shall I turn this?
1 minute, sir.
Sir, velocity will also be opposite to displacement.
Velocity will not be opposite. Where did you prove that? Did I prove that?
No, sir. I'm not sure.
Acceleration directly are getting this. This equation itself reveals. In the acceleration
Yes, sir.
equation, what you have?
Sir, minus. Minus.
Minus omega square y. Okay, sir.
See, many people have a wrong conception that velocity and acceleration are linked. Velocity will always tangential to the path. Acceleration may be in any direction. In circular motion, the acceleration is, there is centripetal acceleration that is perpendicular to the velocity, and there will be there will be centripetal acceleration perpendicular to velocity, and tangential acceleration parallel to the velocity. So there is no link between these two. Somewhere in school, this was loaded. Velocity is tangential to the path. Acceleration is applied force. Suppose you are going in a vehicle on road. Your velocity is the direction of motion of the vehicle. Some fellow comes and hits your vehicle by cycle, and he may hit it in any direction, no? There is no rule that I should be parallel to the velocity, no? That means he can apply a force in any direction. That means you can impart an acceleration in any direction. Understood this?
Yes, sir.
Yes, sir.
Most of your physics becomes difficult because of the wrong concepts you learned in schools. That is the problem we are facing. Yesterday that CBSE fellow is talking something about waves.
Amplitude, sir.
Wave is totally different. That analysis you have in second year. Until then, don't talk about things. Have a complete knowledge when about anything. Why I don't speak Hindi? Not that I don't understand, I know. Problem is I am not well versed like you people. So if unless I poke into that, again like dogs will be bark and pounce upon me. I have to shut my mouth. Why I am able to shout with physics? Because I can bark on you, no? The command over anything makes you the supreme personality in the society. And half knowledge is very dangerous. Shall I turn this?
Yes, sir.
Yes, sir.
Yes,
So
sir.
now this is there are two positions. This is positive extreme. This is y is 0, y is plus, y is minus a. So remember that the particle what you got here, what you have, velocity is 0, but there is an acceleration. Therefore, even though it is red, the force will pull it like this. Here there is no acceleration, but there is velocity.
Sir, omega square A, sir.
Understood this?
Sir.
This velocity is omega a. Again it goes over here. What will happen here? Velocity is 0, but there is an acceleration, a max. For that reason it comes back. Again it reverses like this. Here a is 0. Velocity is maximum. Again it goes. Why? Because of velocity it goes. It comes to rest. Here velocity is 0, but there is an force, that force tries to restore. So like this the particle will be oscillating. Understood this?
Yes,
One
sir.
second. Is it clear? Now you can see velocity direction may be in anything. See, acceleration is always towards mean position. So velocity may be in any direction. This is y equals to 0, no? Suppose the particle is moving. This is the direction of velocity. Suppose the particle is coming like this. Suppose the particle is here. It's the direction of velocity. Suppose the particle is coming towards this. So velocity may be in any direction. But remember that acceleration is always in which direction?
Towards the equilibrium position.
In the position, there is no doubt in that. Second thought should not be there. Followed?
Sir.
Like that only waves also, you don't create wrong concepts, man. Shall I turn this? That you are going into professional courses where applications are utmost important, no? This mugging up, what you'll do? You open a medical shop, that's it. Or Michbaji, something. Shall I turn this?
1 minute, sir.
Remember, velocity may be towards or away from the main position. Okay, but acceleration is always towards the main position, and displacement is always measured from the mean position to the location of the particle. These 3 points, you know, no? Is it clear?
Yes, sir.
Yes,
Clear.
sir.
Shall I turn this?
Yes, sir.
Yes, sir.
Yes, sir.
Now let's come back to the SHM. You know, when you talk about energy, when you speak about energy, what you have, man?
Kinetic energy, potential energy, sir.
Kinetic
So the first
energy and
thing is
potential.
mechanical energy we are speaking about. Therefore, you have kinetic energy. Half mv
V square.
square. Remember this?
Sir.
Is it clear?
Yes, sir.
Yes, sir.
Then you know that you can, there is no nothing like how do you define potential energy? See, you know that du by dy is F, that is minus ky, no? Remember in SHM?
Yes, sir.
Acceleration is so this is F, k equals m omega square. Can I take like this? Understood this? Hello.
Yes, sir.
So now d is minus ky dy. Integrate this. Okay. This is at mean position. Let the position at extreme or any other position. So u minus u naught minus ky square by 2. Do you agree with this or not?
Yes, sir.
So this is do you agree with this or not?
Yes, sir.
Sorry, there's a mistake I think. No? Minus dou u by dou y is x. Remember, force is this now, F is equal to minus dou u by dou y, no? Hello? Hello?
Sir.
Yes, sir. Yes, sir.
Yes, sir.
This minus won't be there. Understood this? Is it clear?
Yes, sir.
Yes, sir.
This we learned in work for energy. Am I right or not?
Yes, sir.
See, all are interconnected, chapter to chapter, chapter to
Yes,
the.
sir. We learned, sir.
Finished this?
1
Hello.
minute, sir. 1 minute.
Fast, man.
Completed, sir.
So you got the potential energy. What is U naught?
In position.
If and only if
Main position. Not in
understood this. Is it clear?
clear.
Therefore, agreed. Now you can see mass is constant, particles moves with constant omega, amplitude is constant. Amplitude is nothing but the radius of the circle, no? Okay, so that means it's always constant, no? It is independent of y, no?
Yes, sir.
Follow this. Kinetic energy changes with y, potential energy changes with y, but the total energy always remains constant. Agreed.
Yes, sir. Agreed.
Completed?
1 minute, sir. Done, sir.
Finish?
Yes.
See here, there is one term. What is V? See, this is what we call it as phase. So this is what is phase, I'll tell. Phase let us see what importance it has. For example, we have if phase is 0, then what is y? What is velocity? This is positive or negative? So what information you are getting? That means the particle is located at which position? Mean position. And it is moving toward velocity is positive means this side only, no? So this implies that phi phase is 0 implies particle is at which position?
Equilibrium position.
Mean position. Okay, moving towards what?
Positive extreme position.
Positive extreme position. So understood this? Suppose we have if phase is pi, then what is y or pi by 2? What is y? A sine pi by 2 a. Okay, what is the velocity? Omega cos pi by 2 0. That means, what is the meaning of that? Particle is
Mean position.
at positive extreme position. And is momentarily at rest, not permanently. It will again come back now.
Stirring force, sir. Yes.
Permanently at rest means it won't come back. So we have this position. V is 0 and this is plus A. Particle is located here. Understood this? There is an acceleration, of course. Clear? Shall I turn this?
Yes, sir.
1 minute, sir. Sir, can you show the previous page one, sir?
Why, man?
Last line adding side, sir.
Note on this. Wait.
Yes, sir.
Shall I turn this?
Yes.
Completed? Now suppose you have the situation in phases, then tell what is y.
Negative.
What is the meaning of that?
Negative extreme.
Particle is where?
At the mean position, moving towards the negative extreme position.
Mean position.
Understood this?
Yes, sir. Yes.
Now suppose phase they give it as 3 pi by 2. Then what will do? Sin 3 pi by 2 is how much? Minus 1. Remember?
Yes.
Do you agree with this? So now you can see
negative
particle is where?
At the
Negative
extreme
X.
negative position. Momentarily, velocity is zero.
Understood this?
Yes, sir.
Shall I turn this?
1 minute, sir.
Finished?
Yes, sir.
Then suppose, right, fast. Shall I turn this?
Yes, sir.
Now suppose the phase is 2 pi. What is the meaning of this? Again, velocity is positive, no? Therefore, particle is where?
At the mean position.
Understood this? So from all this, what you can infer? So we can say that phase
This is the
of an oscillating particle gives information about its position and direction of motion now.
yes, sir.
Yes, sir.
Understood this?
Yes,
Is
sir.
it clear?
Yes, sir.
Yes, sir.
Clear, sir.
Shall I turn this?
Yes, sir. Yes, sir.
then phase at any time okay at t equals to 0, what is the phase? Okay, so this phase epoch. Understood this?
Yes,
The
sir.
name given.
Yes, sir.
For example, then positive extreme, no?
Yes, sir. Positive.
See, remember that it's a circle. This is phi. Now at t equals to 0, it is pi by 2 means pi is pi by 2, no? Clear?
Clear, sir.
Yes, sir. Clear.
You return this.
1 minute, sir.
Completed?
Yes, sir.
Yes, sir.
See, you had seen that what is KP? Remember?
Yes. Yes, square minus ratio.
Now at mean position, y is 0. So P is minimum, no?
Yes, sir. Minimum 0.
K is
Maximum.
Maximum.
similarly, what is P?
Maximum.
Maximum, no? Y is maximum, no?
Yes, sir. What is that?
Minimum.
Do you agree with this?
Yes, sir.
Shall I turn this?
1 minute, sir, please.
Wait, sir.
Shall I turn this?
Yes, sir.
See here, okay.
Yes,
Versus displacement. You can see that at y equals to 0, what happens? Potential energy is how much?
Minimum 0, sir. 0.
0. Okay. Then what is the at extreme position?
maximum,
It
Maximum,
sir.
sir.
has maximum now. What is the maximum value?
Half
half
omega square a square.
omega a square.
So the graph will be like this now.
Yes, sir. It's parabolic.
And
Agreed?
Agreed, sir.
And this will be potential energy graph now.
Potentiality. Yes, sir.
Now can you tell how the graph looks for kinetic energy?
Just the opposite, sir.
the
Turn
opposite
upside
side.
down.
At extreme position it is 0, mean position it is maximum. So the graph will be like this now.
Yes, sir.
This is for kinetic energy.
Yes, sir. Total energy
Variation of kinetic energy with this displacement. And what about the total energy? Can you tell?
constant,
Total
sir.
energy remains constant now.
Yes, sir.
Yes, sir.
Straight line.
Total energy is always this only, no?
Yes, sir.
Understood this?
Understood, sir. Yes, sir.
Understood.
Shall I turn
Yes,
this?
sir.
That means PE decreases, KE increases. When PE becomes 0, KE reaches its maximum. When
Mhm.
KE decreases, PE will increase.
Yes, sir.
But total energy always remains constant.
Constant,
Constant. Yes, sir.
Understood this?
yes, sir.
Understood, sir.
Yes, sir.
Understood this? Shall I
Sir.
turn this?
Yes, sir.
1 minute, sir. Please, sir.
1 minute, sir.
Shall I turn this?
Yes, sir.
Yes, sir.
Yes, sir.
See, what is the total energy?
Sir, half m omega square a square.
Total energy is half,
M omega square a square.
and K is
Uh,
Half omega square a square
minus
minus a square.
so what is asking? What fraction is asking? No?
yes, sir.
How much you're getting?
Oh, 3 by 4. 3 by 4.
Understood this?
Understood, sir.
Shall I turn this?
Yes, sir.
1 minute. 1 minute.
Is it clear?
Clear, sir. Completed, sir.
See, suppose we are having a spring block system. Now the spring is at its natural length. So what is the spring force?
0.
0.
Zero.
So spring force is 0. Normal reaction mg. Now, so all forces. So blob is in.
Equilibrium.
Equilibrium.
Now from this equilibrium position, you are extending this. That means you have extended by x. Now what is the force on that? There is a force here, no? Spring force.
Yes, sir.
Yes.
A.
Now you can see F is minus kx. Can I write like this?
Yes, sir. We can do.
Yes, sir.
Huh?
Yes, sir. We
Now
can
this
do.
is, so what is the acceleration?
F by m
Fine.
minus k x bar by m.
Okay. Now we can see that
Omega
acceleration,
minus omega square x.
you agree this is the equation of SHM now? Okay. So comparing, we have, what is omega square?
Minus k source. K by m source.
Zero.
under root of
So what is the time period of SH of block? Is time period is how much? 2 pi by omega. Yesterday we derived this.
yes, sir. Remember 2 pi by k.
This is 2 pi root over m
By
by k. Understood this?
understood, sir.
Understood.
Is it clear or not?
Clear, sir. Clear, sir.
This is only we say understood this?
Understood, sir.
So return this.
Sir, 1 minute, sir. Please, sir.
Finished?
Yes, sir. Complete.
Is it clear?
Clear, sir.
Yes, sir.
Right. We'll continue in the evening. Okay? At 3:45.
Okay.
Any doubts are there? Right.
Sir.
No, sir.
Go ahead.
Yes, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye bye bye.
Sir, class closed.